Hello guys, welcome back to Maths on African Motives. In this platform, we shall be working on the trigonometry part of mathematics M3, which is one of the important parts that we are supposed to consider in our syllabus, the trigonometry part. So this is the trigonometry that you're going to have. We're not going to waste much time, guys. We're going to really rush through the questions that we are given so that we can see how we're supposed to attempt these typical questions. The first part was to use the basic trigonometric identities. Take note, we are using the basic, which means the ones that we have in our syllabus, to prove the identities, okay, to the trigonometric identities that we're going to prove that, all right. Sine B over 1 plus cos B plus 1 over tan B is equivalent to 1 over cos B plus that is the product, sorry, of tan B. Okay, so I'm just going to rewrite the question aside so that you can see how we're supposed to simplify this typical question. Okay, this is too much. Let me try to reduce, guys. All right, we are given on question 6.1 that the sine of B over 1 plus the cosine of B plus 1 over tan of B. So if the tan of B is equivalent to 1 over, okay, so this is 1 over the cos of B, tan of B. Okay, so that is the question. So for this typical question, we are supposed to check the side that you're going to work with. Is it from the left-hand side to the right-hand side or the right-hand side to the left-hand side, depending with what you have from the question, the most complicated part. And also I explained from the previous class that we had that we can have a direct answer that is a direct answer when you prove from the left-hand side to the right-hand side, or you can have an indirect answer that you're going to prove also from the right-hand side. So we are going to check which one is it from this part. Okay, so I'm going to take the left-hand side in this case. So from the left-hand side, we are given that sine of B over 1 plus cos of B plus this. So we can actually add this. So I'm not going to rewrite this. I'm going to start by adding because these are two fractions that we have. Knowing that 1 over tan is same as cot, okay? So 1 over tan is cot. So we're going to add this part, which is going to be sine of B, which is, there's nothing that we can do on sine B. So just have to rewrite as it is. Okay, everything over the cosine or 1 plus cos of B. Okay, so this is 1 plus cos of B. Also on cos, there's nothing that we can do. So we just have to rewrite as it is. All right, so from this part, if we are to add, we can see that this is 1 over tan B. Okay, 1 over tan B. So it's either way, I don't know which one you're going to use, but what you must know that for tan, it's already, you're supposed to know tan of B is equivalent to the sine of B over the cosine of B. Okay, so that is the identity for tan. But if you want to write as cot, it's 1 over tan is equal to cot. So it's, I don't know which one you're going to take. If it is 1 over tan B, which gives us cot B, we know that cot B is equivalent to cos B over sine B. Okay, so it's, I don't know which way you're going to take, but I'm just going to write this way. This is going to be 1 over tan of B, okay, which is the tan of B, which we wrote as sine B over cos B. Yes, we know that this is the inverse of sine over cos. We know that the inverse is simply means 1 over, like if you divide 1 over A over B like this is equivalent to B over A. So that means from this identity, what we simply need is to find the reciprocal or the inverse of this 1 over sine over cos. So you're going to remain with sine of B over 1 plus the cos of B plus, that is the inverse. You simply need to interchange these numbers. That is the ones that we are given. If it is 1 over A over B, that we just interchange this number B over A. So that is going to be cos over sine. So you're going to have the cosine of B over the sine of B. Sorry, very sorry for that, guys. It was actually very sorry for that. Okay, so from this part that we have, we can find the LCM, that is the LCD of the given denominators, just like the same way that you apply when adding or subtracting fractions. So that is going to be 1 plus cos B sine of B, of which you can just write it as sine B into 1 plus the cosine of B. All right. So you know that if you are adding or subtracting, you have to divide the LCM divided by the denominator. That is, if you divide these two, 1 plus cos and 1 plus cos will actually cancel each other, which means you're going to remain with sine B. And whatever that you remain with, know that it's supposed to be multiplied back to the numerator here, which is to the sine of B. So we are going to have sine B times sine B, which is sine squared B. Okay, plus we move on, sine B here, if we divide this sine B and this bracket to this sine B, the sine and the sine will cancel each other, which means you remain with the bracket of 1 plus cos B. So it is going to be cos of B in the numerator multiplied to 1 plus the cos of B. So that's why I'm opening the bracket, because you're actually multiplying each and every term. All right, so let's see what you're going to have from the left-hand side. Are we going to obtain a direct or an indirect answer? You can expand the brackets here, sine B. There's nothing that we can do here. So that's sine squared B plus cos times 1, that is going to be cos B. Then cos times cos, that is going to be cos squared. Okay, so you're going to have the cosine of B plus cos squared B. Okay, everything over the denominator. There's nothing that you can do in the denominator, guys. Just leave it as it is. Do not do not expand the brackets, just leave as it is. So you're gonna have sine of B into 1 plus cos of B. All right, so this is what you're going to have. From the numerator, there's something that is happening, which is one of the major parts that you're supposed to understand from your identities, that the cosine of B, when it is the cos squared of B, actually, okay, we've got the cos squared of B plus the sine squared of B gives us a 1. If you square a cos and you square a sine added together, you obtain a 1. Whether here you write as x, m and m, whatever letter or number that you have, you're going to obtain a 1. So we need the condition of having cos squared added to sine squared so that we can obtain a 1. And this is the case that is happening here. If we are to check here, we've got sine squared versus the cos squared at this side. So if we add sine squared and cos squared together, we obtain a 1, just like what I was explaining here. So this part, okay, let's see if we are going to have our question back, guys. All right, just sorry for that. Let me try to regain our question. All right, our question back, guys. So this is the part that we are going to have. So you just have to substitute 1 in place of sine squared plus cos squared. So you're going to substitute a 1 in this case. All right, so let's substitute a 1 and see. So we are going to have 1 plus the cos of B. The cos is having a positive, so it is going to be 1 plus cos of B, everything over the sine of B into 1 plus the cos of B. Okay, there's something again that is happening here between these two. 1 plus cos B, 1 plus cos B. These two are the same, so we can cancel out here. So you're going to remain with 1 and 1 here. So at this moment, if we are to simplify, we are just going to remain with 1 on the numerator. In the denominator, we are going to remain with the sine of B. Okay, 1 over sine B can be written as cosec B. Okay, 1 over sine B, that's cosec B. So let me just write it down so that we check with our answer. 1 over the sine of B is same as cosec B. So let's check if we are having these two answers, because that is the simplest form that we can have in this case. Okay, let's get back to our question. Sorry for that. I think I left my question on top here. All right, so we are not obtaining exactly what we had, because you're supposed to obtain 1 over cos B tan B. But in this case, actually, I wrote this. I wonder why am I actually going back, because I wrote this here. Okay, so we are supposed to obtain 1 over cos B tan B. This is the part that you're supposed to obtain. We are not having this condition because our answer is 1 over sine B. So that means we are going back to this condition, to these two conditions that I explained, that you can have a direct answer or an indirect answer. An indirect answer is the one that you simplify, but you do not obtain exactly as it is on the right-hand side, but they are actually the same. So what are you going to do? You are going to take from the right-hand side and prove from this side if we are obtaining the same thing. Okay, so let's prove from the right-hand side and see what we have. From the right-hand side, we are given that 1 over cos B tan B, okay, of which we know that this can be written as 1 over the cos of B multiplied to tan B. And I explained that tan B is same as sine over cos. So this is going to be written as the sine of B over the cos of B. Knowing that any number can be written as over 1. So that means these two can cancel because we are multiplying here. So the cos of B in the numerator versus the cos of B in the denominator can cancel each other, then you remain with the sine of B. So you're going to have 1 over sine B. So take note, if you simplify from the right-hand side, you are obtaining 1 over sine B, which is the same as the one that you obtained when you were simplifying from the left-hand side. Remember, we simplified from the left-hand side here. We obtained 1 over sine B. So therefore, we can state that these two, they are the same. Therefore, the left-hand side is actually equivalent to the right-hand side. That's proven. So these two are the same because we've managed to obtain the same answer, but working from different angles. If working from the left-hand side, working from the right-hand side. So these are the typical questions, guys, that you're supposed to work with and revise as much as possible. Okay, let's check the other part of the question, which is now on 6.2. That was 6.1. So let's check here. That's our 6.2. So 6.1 was actually having 5 marks. Just check, guys. This is a lot. Okay. So on 6.2, you're given calculate the values of x. So we want to calculate the values of x. With that, we will satisfy the following equation if x is greater than or equal to 0, but less than or equal to 180. So we're given that our x must be greater than or equal to 0, but less than or equal to 180 from this identity that we have. All right, let's just save our equation and see how it's supposed to solve this. So that was 6.2. So we've got a 6.2 where we are given the sine of half x, okay, plus 10 degrees is equivalent to a 1. Okay. Take note, we are supposed to solve for the values of x. And this is affected by sine. So how do you remove the sine that is on the left-hand side? So to remove the sine, you just introduce arc sine. By introducing arc sine, it is going to remain with this whole expression, but on the other part, you can write that is arc sine of 1. Okay, so arc sine, I'm simply saying this, let me write down. So you're going to have 1 over 2x plus 10 degrees is equivalent to the arc of sine like this. That is sine to the exponent of -1 like this. So that is arc sine 1, which is from your calculator. That is shift sine. Okay, let me just share another screen, which can allow us to have a calculator here. All right, let's think you can see the calculator now. So arc sine 1 is simply shift sine that is here on sine. You can see on top there. So shift sine of 1, okay, we've got this part here, that's shift sine of 1 is going to give us 90 degrees. Okay, so which means from this part here, we can tell that the angle that is between the region that our x was given, remember our x was given that it must be greater than or equal to 0, but less than or equal to 180 degrees. So from 0 to 180, the angle that is going to give us a 1 is 90 degrees, which is the one that we got. So we're going to have half of x plus 10 degrees is equivalent to arc sine of 1, which is the one that we got here, arc sine of 1, which was 90 degrees. So this is going to be equivalent to 90 degrees. So take note, even you can obtain this answer from the normal sine wave, because this is the graph of sine. So we know that from the graph of sine, where sine is equivalent to 1, okay, this is the graph of sine that we have, which is taken like this, that's 0 here. So let me just draw first, okay, like this, okay. So this is 0, 90 degrees, 180. So we've got, all right, let me just do this, guys. All right, the way, okay. So we are going to have 0 degrees here, 90 degrees, 180 degrees, 270 degrees, 360 degrees. Okay, that's at -1 here and at +1. So this is the y-axis and the x-axis. So at 90 degrees, we can actually see that the graph corresponds with a 1. So the arc sine of 1 gives us 90 degrees. Just like at 0 degrees, we have got 0 at 180. So we only have one value of x, which is the angle that gives us direct 1 from 0 to 1, even if it was from 0 to 360. We have got one angle which gives us direct a 1, which is at 90 degrees. So this is the one that we are having here, the 90 degrees. So how now are we going to solve for x? So like I said, you can take it from the calculator or from the graph, okay? So from this part, we can transpose 10 degrees to the right-hand side is going to be -10, which is 80 degrees, because it's going to be 90 minus 10 degrees, that is 80 degrees. All right, so to find x, you can cross multiply because this same as over 1. So 1 times x, that is going to be x is equivalent to 2 times 80, which is 160 degrees. Okay, so that is the value of x from the region that we were given in this case. So from this interval from 0 to 180, 160 is there. So which means this is fine. All right, let's check the other part of the question, which is 6.3. We are given that study fig 2. Okay, so you're supposed to study first. Okay, so this is our fig 2. I just want you to study it and see what is happening before we read the information. So that is the diagram, guys. We can see that we've got 90 degrees here, 90 degrees here. We've got a quadrilateral and a triangle and another triangle again. Okay, so let's read the information now. AB is a building 30 meters high. Okay, so AB is a building, okay, which is this AB. This is a building, all right? So from A to B, we've got a building here. So this is our building, which is 30 meters high from A to B, okay? Then what happened to this building? All right, we are given that X meters away from a nearby tower CD. Okay, so we've got a building, then we've got CD, which is representing a tower. So this CD, that's our tower here, which is actually, okay, let's see CD there. So this H is the height of the tower. Okay, so we are given that it is actually X meters from the house. The building and the tower stand on a same horizontal plane, which means the line that we see is a horizontal line. That's why we said it's 90, because we put vertical and horizontal, which gives you 90 degrees. The angle of elevation to the top of the tower is 45. That is this angle that we see from the building. Looking at the top of the tower there, the angle is 45 degrees. And from B, it is 60 degrees. And from B here, we've got the same, looking at the same point, which is the point B here. Looking from A, the angle is 45 degrees. Looking from the point B, the angle is 60 degrees. So that's what we have from this diagram. So I think you understand the diagram, guys, and the angles. So the question is, determine H, that is the height of the tower. So where and how can we have this H, the height of the tower, CD, this H, this is our CD, which is H. All right, so in this case, there can be so many ways that you can use. There can be so many ways, but I'm just going to explain the one that was easier for me when I was actually working with these questions. All right, if you are to check from this part, we do not have direct information that can lead us to CD. All right, take note, the triangle B, CD, this triangle, we only have an angle inside. We do not have any side that is affecting this triangle. So the moment we can have a side that is affecting this triangle, it means we can calculate that value of H, which is the height of the tower. So that is what we actually need to do in this case, to calculate any side, as long as it's possible to calculate that side. Okay. What you're going to have in this case, we are going to try to calculate the side side BD, because if we can have maybe a side BD, this side BD, we can calculate the height. How can we calculate this? let's take a consideration at angle A, because actually let's start by filling so that we see. At angle A, remember, this is a rectangle, so this is going to be 90 degrees, and we've got 45 degrees. So if we add 90 plus 45, the whole of this angle, we are going to obtain 135 degrees. Okay, so we've got 135 degrees. Then we move on at this point. Remember, we are given that the whole of this angle is 90 degrees. But at this point, which is the one that we are having the angle of elevation, which is 60 degrees, that means we are going to have a remaining angle inside triangle ABD. We are working with triangle ABD. So inside this remaining, inside this triangle, there's a remaining angle from 90 degrees. So 90 minus 60 degrees, that is going to give us 30 degrees. Okay. So definitely we can apply the whole triangle now to calculate the angle at D. Remember, we are working with triangle ABD. Okay. So to calculate the angle at D, we are simply going to subtract these two angles from 180. Why? This is a triangle, guys. Angles in a triangle, they add up to 180 degrees. All right. So the angle that is affecting at point D, it is going to be equivalent to 180 degrees minus the sum of these two angles, that is 135 and 30 degrees. We've got 135 degrees plus 35 degrees, which is going to give us 15 degrees. All right, so this is what you're going to have. So this is 15 degrees. From this part that we have, guys, we are now having a triangle with angles inside, but we only have one side, which is 30 meters. So what can we do now with this triangle? All right, let's check how the sides and the angles are related and what we need from this part. Remember, our major issue is to find a side which affects triangle BCD, the one that is got edge. So definitely the side that we are focusing with is this side, which is side BD. So we are focusing on side BD. All right. So I want you to see something here. From the side of 30 meters, it corresponds back here with 15 degrees. These two, they are opposite to each other. They correspond with each other. We want to calculate side BD, which is this side, and it corresponds with an angle of 135. So they are opposite to each other. Whenever you are given this type of a condition, that's where we apply sine rule and we are calculating a side. Okay, so taking note from our sine rule that, okay, so this is 6.3. So we're going to take note from our sine rule. I told you guys, if you're calculating sides, you can write the sides on top. Yes, you can write it as sine A over A, but you can just write it as A over the sine of A is equal to B over the sine of B. If you're calculating sides, just write the sides on top. So we want to calculate the side CD. So we saw that CD over sine of the corresponding angle at that CD that we have, because this is the side that you have to calculate. Is it? No, that's not CD. That's not CD, that's BD. Okay, that's from side B to D. So it's BD over sine 135. Okay, so you're going to have BD over sine 135. So this is BD over sine 135 degrees is equivalent to what we are given, and it's a complete combination that is going to be B over sine B. So do we have a complete combination? Yes, that is the one that is got 30 and 15 degrees. So it's 30 over sine 15 degrees. Okay, so we're going to have 30 here. So that's going to be 30 degrees over, okay, not 30 degrees, because this is 30 meters. This is distance. Okay, sorry for that. Tired. Okay, so it's 30 over the sine of 15 degrees. So that's what you're going to have. So how can we solve for BD? We can see that the sine of 135 degrees is dividing. So how do you remove this? You simply have to multiply by sine 135 degrees, both sides by sine 135 degrees. Or you can cross multiply, then after cross multiplying, still you're going to divide by sine 35. So I don't know, maybe it's best for you guys, but it's fine. So BD is equivalent, this is same as over 1. So it's 30 by sine 135 degrees, which is 30 sine 135 degrees over sine 15 degrees. So this is what you're going to have. And thus we can use our calculator to solve for BD. All right, so I'm just going to share back that screen that we had so that you can see here. All right, so this is what you're going to have. From our calculator, we just put a fraction. Make sure that your calculator is in degrees, okay? So this is 30 sine 135 degrees like this. Okay, everything over sine 15. So we've got sine of 15 degrees. Okay, so that's 30 plus, but you can write as a decimal, which is 81,965, which is 962. So it's 81,9 and so forth. 81,962 meters. Okay, the distance is there. Were written in meters from the one that we're given on the diagram. That was 30 meters. So that's what we know so far. All right. So we have managed to calculate BD using triangle ABD. We now have this side here, which is our BD. And we are given that this BD, the one that we just calculated, is 81,962 meters. Okay, so that's your BD. So like I was saying that if we can just have one side, as long as it's a side in this triangle BCD, we can be able to calculate H, which is the length of CD, the one that we are required to calculate. How is that possible? This is a right angle triangle. So from a right angle triangle, we can know that we've got an angle of 60 degrees. And according to 60 degrees, H, which is side CD, is opposite to this angle of 60 degrees. They are facing each other, so we've got an opposite here. And 81,962 meters is actually opposite to 90 degrees. It's facing 90 degrees. That's the hypotenuse, which is the longest side. The longest side is the one that faces 90 degrees. So you're actually asking yourself, which ratio am I going to use? Because these are trigonometrical ratios. Which ratio am I going to use, which applies the sine, the opposite, and the hypotenuse? Already I've told you the answer, guys. Okay, anyways, how do we take this answer? We are going to use this concept from our sine ratio. This is not sine rule. This is sine for the ratio, which states that the sine of, okay, so let's see from where we left. So now let's just write something, guys. Which triangle are we using? So this is in triangle BDC, the one that we had. Okay, which marker did I use now? Okay, so that is from this triangle. So we said which ratio we're going to use from our SOHCAHTOA. So this is SOHCAHTOA. So from our SOHCAHTOA, we can see that the sine is equivalent, is the one that has got opposite and the hypotenuse, because we need a ratio which applies of a sine, which applies of the opposite and the hypotenuse at the same time. So substitute the values from into the formula. We have our formula. So our opposite is the H, the hypotenuse 81,962, and the angle, that is the angle of 60 degrees. Okay, so let's substitute there. So it's going to be sine theta here. Let's just write the sine of theta, which is opposite over hypotenuse from our ratio. So that is the sine of theta, which is the angle, is equal to the opposite, which is the side that is opposite, which is H. So it's H here over the hypotenuse, which is 81,962. Okay, so we're going to have it as H. Yes, you can write it as CD, it's fine, but you can just write it as H, since CD is represented by what? By H. So it's going to be opposite, which is H over the hypotenuse, and the hypotenuse is the one that we said is 81,962. So to find H, definitely you can cross multiply here because we've got our two fractions. So it's 1 times H, 81, this times 60, sine 60 degrees. Okay, so 1 times H is H, which is equal to 81,962 multiplied to sine 60 degrees. Okay, so that's you and your calculator again, guys. So let's see what we have from our calculator. I hope the screen is still the one that has got everything. So we've got 81 here. This is 81,962 times the sine of 60 degrees. Okay, so that's sine 60 degrees, which is going to be 70,9811 and so forth. So this one cannot change the other one. So it is going to remain as 70,981 meters. So that was h, which is the height that you are given in this case. So it actually depends with the which ratio did you manage to use, because there are so many ways that you can actually have this answer. So for now, let's just work with this. But if you've got any other method, then let us feel free, guys, to mention it on the comment section so that we can have, or we can work from that angle again with others so that they can benefit from that information that you have given us, guys. Okay, on question 6.4, we are now asked to draw the graph of f of x, which is equivalent to 5 sine 4x, okay, from 0 to 90 degrees. Show the coordinates of all the turning points and the intercepts with x's. Okay, I explained this typical question in another platform. I don't know if it was for the members only videos, but I still remember that I explained this typical type of a question. Okay, let's write our question down so you explain the other part later on. Okay, so you're given that this is f of x, which is equivalent to 5 sine 4x, okay? And our x is supposed to range from 0 degrees to 90 degrees. Okay, so that's what we have, and showing the intercept and so forth and so forth. So forth. Okay, I explained previous that if you are to sketch, to draw, actually you're drawing on a graph paper, but here I'm just going to show you the sketch, how it's going to look like. What you need is a table of values. That's the easiest way that you can use. But from the table of values, you take direct from how the graph of sine was drawn previously. We know that the graph of sine of x is supposed to be like this. Okay, so this is the graph of sine of x, which is something like this. Okay, where we have got our angles here, which is 0, 90. I explained this one again, if you still remember, 270 here, 360 degrees at -1 and at +1. Okay, I explained this graph before, if you still remember. This graph was actually having an interval from 0 to 360 degrees. And if we are to check, we were separating this graph by an angle of 90 degrees. It was 0, 90, 1. We are adding 90, 90, 90, 90, 90 throughout. So it's a direct graph which affects the graph, which is the graph of sine x. If we are having direct x here, which means we are having our x equivalent is like 1x, 1x. Okay. Now, if you are to check here, this is now written as 4x. This is the part that is important. Okay, this 5 does not mean, because the 5 actually, it represents the amplitude, which means your graph now, it is going to pass at the maximum value, it is going to be +5. The minimum value is going to be -5. That is what this 5 represents. So the major part is this 4 that we see. It plays a role to find the new interval that you're going to use. So what is going to be the new interval? You equate 4x to the original, the old interval that we used to have, which was of 90. Remember, I said these angles were separated by 90 degrees. So you equate 4x to 90 degrees so that we have the new interval from this. So you're just going to divide. You're going to divide, which is x is equal to 90, divide by 4, which is something like this, guys. And that's 90 here, divide by 4 degrees. Okay, divide by 4, not 4 degrees, but just 4. We are going to obtain 22.5 degrees. So which means each angle now is going to be separated 22.5 from each other. 22.5 instead of having 090, 180, 270. No, we are no longer having this. So our table of values now can be drawn like this. Remember, this is the graph of f of x, which is equivalent to 5 sine 4x. And so we are going to have our table here. So let me just try to draw our table. So that's what you're going to have. Remember, it's from 0 to 90 degrees. This is what you're given, from 0 to 90. All right, so let's see what we can have here. So this is x and y. All right, so our values. So okay, let's just insert our values from this The first one definitely is going to start at 0 degrees. So you're going to have x being equal to 0 degrees. But remember, we said we are now separating these angles by 22,5. So 0 plus 22,5, that's 22,5 degrees. Okay, you move on to the other value, which is you add 22,5. So already we've got 22,5. We add another 22,5. We are now at 45 degrees. So the following angle is going to be 45 degrees. You add 22,5 and so on, which is going to give you 67,5 degrees. You add 22,5, which is going to give us 90 degrees. So that's what you're going to have at the end. All right, so from this part that we are given, take note, we are supposed to draw now the graph that is going to affect these values. But we cannot just draw these values because we do not have the corresponding values of y. So that means going back to your calculator, substitute the values that you're given. When x is 0, what is the value of y? When x is 22,5. So this you just write direct on your calculator as it is. That is 5 sine, then 4 times now. The first angle is a 0. So 4 times 0, you know it's a 0. So you're going to obtain a 0 there. We move on to when x is 22,5. We just substitute in place of x, you substitute 22,5. So this is what we have in place of x, that's 22,5 degrees. Okay, that's 22,5 degrees like this, which is 5. So this is going to give us 5. You move on to 45, you do the same. Okay, so this is going to be 4 times 45, which is a 0 there. 67,5, which is the same, that's -5. At 90 degrees, that's the same, which is a 0. So you just substitute direct. Okay, so as I was saying, the graph of sine, its shape is not going, we are going to have the same shape as this, the same shape. The only thing that is going to change are the points now, which is the interval is now 0, 22,5, 45. Okay, let me show you that this shape is not going to change. We are going to have the same shape, only different points this time. All right, so our graph, like I explained before, we are going to have something of this nature. Okay, this is ugly now. This is now ugly. Okay, let's just see this way. All right, we are going to have our graph in this way, guys. We've got the values of x and the values of y here. So we're going to start at 0 degrees. We move on to 22,5 degrees. We move on to 45 degrees. You move on to 67,5 degrees. You move on to 90 degrees. So these are the values of x. For the values of y, as you can see, the maximum is 5, the minimum is -5. Like I just explained here, that is what this 5 is affecting. It's just affecting these values 5 minus 5. So that one, we are not worried about it. So you can just write 0 here. Then we can just say this is our 5 and this is our -5. Remember, this is sketch that we're having. All right, so let's mark our point so that we see the graph that is going to that we are going to have at the end. So that's 0 degrees versus 0, which is at this point 0 versus 0. 22,5 is versus 5. So 22,5 versus 5. So you can just mark at this point. 45 degrees versus 0. So that's 45 versus 0 here. 67,5 versus -5. So that's going to be a -5 here. Then 90 versus 0. So all you need is to join the points and see the graph that you're going to have at the end. Okay, so if you are to join these points, you're going to have something of this nature. All right, something, this is just a sketch, but you're supposed to produce something which is neater than the one that I'm having here. Okay, so this is the graph of sine of y is equivalent to 5 sine 4x. Okay, so that's what you're going to have at the end. All right, so I think you saw how to sketch this graph. So the idea is not to draw this graph or that you are having here. No, the idea is for you to know how to draw typical questions, typical graphs like this one that we are having. There can be so many graphs that you have, but when it is tan, when it is cos, you need to know the basic of a cosine graph, of a tan graph. If you know the basic, then to draw whatever graph, there can be changes like the one that we had, it was now 5 sine 4x instead of being sine x like this one you saw. So you see that this graph that we see, the graph that we have here, it maintained the same shape even on the final answer. We are having the same shape. The only difference now are the points. So if you know the basic of a graph, it is going to be easier for you. It's going to be easier for you because whatever condition that you're given, you just have to manipulate from there to the one that you are used to. So that's what we had, guys, from Meson African Motives. I just hope this is going to help us. Let's revise as much questions as possible. And don't forget to join the membership class, the membership part on your YouTube platform. Just click to join so that you can be part of the members. That's allowing us to revise as much questions as possible. So we have to revise as much as we can, add more questions, add more revisions. And where there are challenges, we can simply communicate through the membership platform. That's what we had actually, guys, for now, for Meson African Motives. Till we meet again.